Welcome everyone. Thank you for joining today. I am Sterly Pauliscat, a graduate research assistant within the WVU prevention team. And I will be presenting on sustainability through environmental product declarations for specifically construction materials. So this topic is timely given our increasing focus on sustainable construction practices and environmental responsibility, especially with the United Nations 2030 Agenda for Sustainable Development Goals. Here is the agenda for this presentation. We will begin by examining sustainability and construction, understanding what LCA and EPD entail, their relevance in the U.S. construction sector, the steps that are needed for creating EPDs, and some challenges and efforts that are being made in the field. And then we will conclude and have time for questions at the end. So the construction industry primarily is consists of establishments related to constructing, renovating, and demolishing buildings and other engineering structures. However, the construction industry, commonly referred to as the built environment, it contributes around 33% of global energy and process-related greenhouse gas emission and requires significant decarbonization to reach global zero net target. Furthermore, it heavily impacts resource consumption and emissions, especially from concrete, steel, and other high energy intensive materials. And due to the growing environmental regulations and climate change mitigation strategies, understanding and addressing these impacts are crucial. Now we'll take a look at what is a life cycle assessment and what is an environmental product declaration. So a life cycle assessment, commonly referred to as LCA, is an established methodology for measuring a product's environmental impact over its life cycle. The impacts may be climate change, ozone depletion, acidification, toxicological stress on human health and ecosystems, the depletion of resources, water use, land use, and noise, and many other impact categories. As we can see in this figure, a common life cycle assessment is commonly divided into 5 stages, in 5 modules. So the first module is encompasses module A1 all the way to A3. And at this stage, it contains the provision of all the materials that are needed um, to actually have the product. It includes the energy as well as the waste processing up to the end of site waste or the disposal of final residues during the product stage. The second stage, which is the construction stage, it includes all the impacts related to the transport to the building site and on-site activities related to the installation, including any waste that is produced and the disposal of said waste. The third stage is the use stage. It encompasses modules B1 all the way to B7. And in this stage, all the impacts related to the use of the building or the product over its entire life cycle. This includes any provision for the transport of all the materials, as well as the energy and water impact associated with the product or the service. The last stage, the fourth stage is the end of life stage. And at this stage, we account for the deconstruction or the demolition of the construction project and includes like all the impacts of transport to waste processing sites and the disposal of said waste. This encourages design teams and construction practitioners to actually consider the environmental impact at the end of life early in the design process and to actually use recyclable and more sustainable products to minimize waste at this stage. The last stage, which is the net and benefit loads, which only includes Module D, it was recently introduced in 2019 to actually cover the net benefits and loads arising from the reuse of products or the recycling or recovery of energy from waste materials of that construction project. And overall, the overall results, including in Module D, they are often referred to as the cradle to cradle approach. And as we can see in the picture, there are different approaches that practitioners can use to actually conduct an LCA. We have the cradle to gate approach, which only includes the first stage. We got the cradle to practitioner up to practical completion, which includes the first two stages, and then the cradle to grave. It includes stage one all the way to stage four, and the cradle to cradle, which encompasses all the stages. Now, in the construction context, this means evaluating everything from raw material extraction, the production, and transportation all the way to the construction process. Um, this includes as well the building operation and eventually the end of life disposal or recycling of the building materials. It heavily relies on background lifecycle inventory databases, which actually incorporates methods for considering various types of data quality characteristics, including completeness and temporal, geographical, and technological representativeness. It is key to understand that there is actually no EPD without conducting an LCA study. Now, what is an EPD? So an EPD is also referred to as a Type 3 environmental declaration. So it is a tool that communicates transparent and comparable information on the environmental impact of a product or a service during its entire life cycle. An EPD's primary purpose is that of an eco label, like a public declaration of a product's environmental benefits. And similar to nutritional labels for food, but applied to building materials, guiding better sustainability choices and construction projects. So below we can see that a four-step view of creating an EPD. So let's start with the PCR. So the PCR is the product category rule that is a document that actually provides all the instruction for how the life cycle the life cycle assessment of a product should be conducted. They ensure that functionally similar products are assessed in the same way when conducting the life cycle assessment for other products. It ensures that many products can be compared on the same basis. It also sets out what you need to consider, including the system boundaries, meaning the processes and stages of the product's life cycle, and the declared and functional unit, which is the amount or the weight and service life of the products that is being assessed. It also tells you about how to define the use phase as well as the end of life options. And also, what are the impacts categories that need to be assessed in addition from the standard sets and the general program instruction, which are the rules guiding the overall administration and operation of a program operator. Now, a program operator is any organization that manages the development and verification of EPDs. For example, we got the International EPD System. We got NSF International in the US as well as UL Solutions and many others. Now let's take a look of some key elements on an EPD document. So to the right, we got an EPD for aluminum soles and granules by Metals, a US company that is a leader in innovative metal production. So we've got the manufacturer and the contact detail at the top, as well as any product information and technical data that is necessary for the product. Next slide. Now we have the life cycle assessment. It tells about the scope, whether it's cradle to gate, cradle to grave, but in this case, it's cradle to gate. And later on in that document, if we kept reading it, we will see eventually the goal definitions, the inventory analysis, the impact assessment that was made, as well as the environmental impact indicators such as global warming potential, acidification, as well as any resources that have been used, the waste generation and emissions of that specific product. And most importantly, the interpretation um, after that LCA study. Now let's take a look at the significance of EPD within the US. Now, the growing market and regulatory demands have made EPD an indispensable tool for sustainability assessment within the US. And these tools are increasingly vital for companies aiming to demonstrate environmental responsibility. The reason is that EPD enable data-driven decisions to minimize environmental impacts by providing standardized metrics like global warming potential, which is how much energy the emission of 1 ton of gas will absorb over a given period, usually 100 years, relative to the emission of 1 ton of carbon dioxide. This is according to the EPA. So as a result, the Inflation Reduction Act, IRA, appropriated $250 million to the EPA in 2022 to actually develop and execute programs for EPD creations. And this funding is designed to support the creation and enhancement of standardized and transparent EPDs, which measure again the embodied greenhouse gas emissions of material throughout their life cycle. Now, EPDs and green building certification. So the industry seems to use EPDs more often because of their adoption as credit and green building rating systems such as LEED and many other certification bodies, as it demonstrates a clear commitment to sustainability. Now, what are the steps needed to create an EPD? Now, if we take a look at this picture, the process of developing an EPD for a construction product is pretty complex. It requires like a thorough understanding of how the data about the environmental performance of the product can be generated, usually using a cradle to grave approach. Now, the first step um, is selecting the product category rule that provides the basis for the data collection and and as well as the how the LCA should be conducted for that specific product. The next stage is to actually, based on the PCR, we can actually find all the rules to conduct the LCA study. And during the LCA study, we can actually collect the information on the product's environmental load over its life cycle. And this entails information on procurement, transport, utilization, and waste accumulation. And afterwards, the acquired information will help in assessing the environmental footprint using any LCA software that is available, such as EcoChain, one-click LCA, and Open LCA. The third step is to actually generate the EPD. So it implies organizing and presenting the data in the standard form provided by the program operator. Depending on the program operator, there are different ways to actually make that report. And the last stage is verification and publication. So it's important to involve a third party, especially if we are doing business to consumers and business to business. Um, so we need a verifier that is acquainted with the program operator and the PCO for that specific product. And after the verification, the EPD is made public either on the manufacturer site or on any EPD platform, such as Eco Platform and EPD International. Now, there are many challenges that have occurred within this field, and we're going to take a look at some of them. So there is this author from Victoria University of Wellington in New Zealand that presented some challenges when actually doing a life cycle assessment and creating EPDs. So they came up with 33 challenges that were later divided into 7 groups. And those 7 groups are data paucity, which refers to a condition that is characterized by a lack of available data. So for instance, there was the incomplete scope definition and missing input data. So it has been reported that LCA practitioners often encounter incomplete project scopes and missing data, directly affecting their ability to actually perform accurate and comprehensive LCA. And this results in inaccurate EPDs because EPDs depend on LCA. Second group of challenges is resource intensive. So it refers to all the activities or processes that require resources such as time, human power, money to complete EPD successfully. Some specific challenges were high time consumption and um, sorry, cost to actually produce LCAs and EPDs, and the financial constraints on small and medium-sized manufacturers. So through a survey, it has been reported that the cost of preparing an EPD and a product category rule ranges between 13,000 and 41,000 US dollars, while the workload is between 22 and 44%. 30, I mean, between 22 and 44 people. This is like a potential setback to small and medium-sized enterprises, which will affect the overall goal of embracing sustainable product development. The fourth group of challenges were related to knowledge or intellectual capital and research. So this refers to the combined value and output of knowledge and expertise within this field to actually generate new insight. For instance, a lack of knowledge, personnel and LCA, and the complexity and lack of knowledge about the uncertainty data that is used in LCA. Next, we got methodological limitation and people. So it refers to like constraints and challenges inherent in LCA methods and skilled practitioner. For example, poor inclusion of uncertainty analysis and current practices and inaccurate estimation of building life cycle. So it's important to note that inaccurate estimation of the building service life can lead to significant errors in LCA results, as it can directly impact the reliability and usefulness of the EPD that is coming out of it. Next, we got the technological dimension. So in this one, we actually use technology to collect and analyze LCA data. For example, some challenges were the lack of automation to actually collect and send LCA data to any EPD tools. And lastly, we got data integrity, which refers to the data accuracy, consistency, and reliability throughout the entire life cycle to ensure that the data remains free from errors. So due to the data intensive nature of LCA, it is necessary to ensure that that all the data collected for that specific purpose is of good quality because its overall impact on the EPD quality, which is widely used for sustainable decision making. Now, the author also provided some strategies to actually mitigate those challenges. Um, so as I stressed before, data is fundamental basis of EPD creation, and the complex data collection process of LCA issue can be enhanced through the integration of purpose-made applications, the adoptions of technologies such as Internet of Things, blockchain, or the integration of enterprise resource planning to actually simplify the process. For example, sensors and ERP system can be deployed to collect real-time data on the manufacturing process, which practitioners can then use to actually conduct the LCA study and have the EPD development there. In addition, it is recommended that governments and program operators should set caps on the cost of EPD creation, which will help small and medium-sized enterprises. Another strategy entails developing country-specific inventory for LCA to actually reduce the uncertainties associated with that study while using available data to fill gaps. It has been found that although a wealth of is already available, EPDs are often too specific for the early stage of projects where specifications are unknown. So building designers need better representative data for early stage LCA. That is why it's recommended that government invest significantly in the development of national LCA databases with data quality assurance. So finally, to promote data interchange, the International Lifecycle Data System, ILCD format, was developed by the European Commissions, which allows users to actually exchange data that was previously thought incompatible, bringing many more data sets and models and methods within the LCA field. So I will conclude by saying that EPDs play a critical role in advancing sustainability practices within the construction sector, as they help to align with compliance requirements and green certifications, as well as promoting enhanced competitive advantage. So widespread industry adoption can be improved by emphasizing first standardization, education, and the inclusion of digital tools, as well as regulatory pressures and market demand. So these are my references. Thank you for paying attention. And this is the QR code to provide any feedback.